Good morning, Shweta.
Good morning, sir.
Okay, let's begin with the class for today. So yesterday's class, we were focusing on discussing the various aspects of growth, correct? We discussed the concepts of, components related to the mainly aging senescence that we discussed about, okay? And also we discussed the few aspects of aging phenomena. And we'll continue with those things today. So two things that we are going to focus more today on. One is related to the major changes that happen in the aging process. Second, we are going to talk about the difference between biological aging and chronological age. Okay, if there is any difference between. So a bit more emphasis on the aging process here. So definition of the aging we have already seen. There are different definitions that are given. We already have seen some of them yesterday. So today I'm going to briefly talk to you about concept behind primary and secondary aging. Aging can be of two different types. One is called primary aging. Second one is called secondary aging. So what is the difference between two? Primary aging is a natural phenomenon. Is a process where we're talking about intrinsic and most likely the genetically pre-programmed nature of cellular longevity, or how long can cells actually divide, how long they can be active. There must be certain criteria that is already put into the place. Our cells are made to survive, let's say blood cells, RBCs, able to survive for about 120 days. So we have certain lifespan for them. Like that, there is inherent or inbuilt program that tells us that this is your expiry date. So if that naturally happens, this is called primary aging. So what is primary aging? It is an intrinsic and most likely the genetic programming that limits the ability of the cells to divide. So this is the inherent process that we notice inside our cells in the aging process. This natural phenomena is called primary aging process. So because of what you are and what is your body built with and how long it can survive in terms of its cells and tissues is the concept of primary aging. The second one is secondary aging process. How is secondary aging different from primary aging? In the secondary aging, we talk about the accumulated effects of the environment that we are living, maybe pollution, maybe alcohol, maybe smoke, all sorts of things that we are exposed to, which also cause damage to our body. So the environmental insult or the damage that we receive from the environment, or maybe because of the disease, trauma, because of the stages that we go through, or the situations that we go through in our life. So something outside, we're talking about extrinsic factors here. So primary aging is a phenomena connected to mostly the intrinsic factors because of the pre-programmed nature of our body, and whereas secondary aging refers to the other problems. So environmental issues, how environment treats us, because pollution can affect our lifespan, diseases can affect our lifespan, right? So this is referred to as secondary aging process when we are considering the extrinsic factors like environment, disease, etc. It is called secondary aging. So primary aging, as per this, it talks about if only primary aging takes place, we should have constant maximum lifespan. In all individuals should have maximum lifespan because we all should have equally or similar programmed system in our body. But that's not the case, right? So primary aging, if is only considered, it should actually provide us maximum lifespan for any species, doesn't matter within a given species. But we see a lot of variability. So secondary aging can explain the variability in lifespan of individuals. Because why some people are dying at, let's say, age 35, age 40. Many people at the age of 30s and 40s also died from COVID-19 recently. So that actually affected their lifespan. Their lifespan is supposed to be better than that. But they died because of a disease that their body could not tackle. So like that secondary aging concept would explain this variability that we notice in the lifespan of individuals. That is the importance of secondary aging. So briefly, if you have to write a short note or explain about it, talk about the concept of primary aging and secondary aging. Just a brief idea on this. Okay. Next, we'll talk about the processes that take place during aging. So we defined aging, we talked about types of aging, definitions of aging. So now we're going to talk about the processes of what changes do happen with aging. So this is an image I have taken from Biological Anthropology by Stanford et al. Okay, I've shared this document with you already. So look at this nice, graph indicating what happens with us when we age. On the x-axis, what do you notice? Age, 20, 40, 60, and 80 years, and so on. And on the y-axis, you are noticing percentage of physical function. So what are we learning here? What is this image showing? This image is showing with age how physiological function is declining. So this is showing that effects of aging on decline in the function, or effects of aging on physiological function. What is happening here? Look at different lines here. Velocity of nerve signal transmission. How fast does nerve signals travel? How fast do you pick up something? How fast do you respond? Don't you see that with age we respond slowly? That is one reason is nerve signal transmission rate decreases. The speed at which nerve signal transmits decreases. Okay, so simple diagram. So where you write x-axis age and the y-axis you write the percentage of physiological function or the effect on physiological function, you can say. So more or less you are seeing the downward trend in all of them. If we have something called 100% functionality as we are growing up in the childhood, adulthood, that would decrease in the middle adulthood and so on. So what are all the problems? Central nervous system is affected, rate at which central nervous system functions is affected. Kidney filtration rate. Kidney's job is to filter the blood and remove the toxins like urea. okay, or nitrogen derivatives that we remove. Excess salts, excess water we remove. So basically what happens in the kidneys, blood gets filtered, but the rate at which this blood is filtered is also affected. So kidney filtration rate decreases. Velocity of nerve signal transmission decreases, kidney filtration rate decreases, and ability of heart pumping the blood also decreases. More or less with little variation, you are seeing the steep decrease. As you're coming down, more steeper decrease can be seen here. What do you see at the bottom? Breathing capacity. Your breathing capacity goes down. Your arm cranking power goes down. Okay. You don't want to, if you don't want to talk about lung volume, you don't need to, because we already talked about breathing capacity. Here we're talking about how much air we can store in the lung. What is the lung volume? Also pumping of efficiency of heart. All these components are affecting it. So breathing rate, so lung function, arm moving function, heart function, kidney function, nervous system function, they all are decreasing over a period of time. So as their outcomes are efficiencies. So memory loss happens over a period of time, right? And also we notice that our high blood pressure, we cannot handle it better. Our walls are weaker. Because of all these components, what happens? Our physiological systems and their efficiency in working decreases. So we become more and more vulnerable to the disease condition and also to the death. Okay, you can use something like this. Of course, you can add a few more components here, like what type of physiological changes that happen associated with age. So you can divide these physiological changes into three groups. What are the one? Changes in the autonomic functions. Changes in the autonomic functions. What are autonomic functions? Functions that we don't have to control. By default, they work. It's like digestion. You eat the food, you can only decide whether you want to eat or not. But once you eat the food, can you ask your digestive system not to digest it? Do you have any control on that? Okay, you can close your nose, mouth, but the process of respiration continues. As far as there is an input of air, there will be output of air. So respiration continues. Heartbeat, you cannot request or beg your heart to stop. It won't stop. These type of functions are called autonomous functions. How are they called? They are known as autonomous functions. Such autonomic functions of the body are affected, which indeed affect the cellular homeostasis or balance in the cellular function. Normally we have, for a given input, we have given output. It goes in a balanced manner in a body, but that homeostasis is also affected. Okay, your temperature, blood volume, hormonal input and output. So these things actually change. So autonomic functions which we don't have control on can change. Next, mass of the organs. Reduction in mass of organs can also be noticed. The first point I told you here, changes in autonomic function. So those that are self-controlled, controlled by the body are changed. Example, temperature, blood volume, etc. Second point, we're talking about reduction in the mass of the tissues or mass of the organ. The size and density has changes. Size of the brain, meaning number of neurons that are active, changes. Number of cells that are actively functioning in the liver changes, they reduce. Kidney, same story. Bone strength decreases. So reduction in the mass of organs and tissues. That is the second point. Third point is the reduction in the organic functional aspect of it or functional reserve of it. Lung function, heart functions that we talked about here in the previous image. These aspects, physiological function, capability, because anyway, as the number of cells are decreasing, our number of active cells are decreasing, so as the functional capacity or functional reserve of it also changes. Okay, what are all the systems affected, which I already talked to you? Different systems in the body: cardiovascular, respiratory, gastrointestinal system or digestive system, endocrine system, hormonal system, skin. Skin foldings are common with aging. Nervous system, so memory loss, being able to process, like how fast old machines, computers work slowly, right? Because the process speeds are weak. Similarly, with aging, what happens? The way we respond, the way we talk, the way we comprehend, all of the symbols of or signals of how well the brain is functioning. So those components are affected. Your ability to control the body temperature is affected. That is also a function of brain. Your immune system, how well do you respond to infections? Okay, so these components. So many systems, actually more or less majority of the systems in the body, lungs, kidneys, heart, immune system, skin, hormonal system, all these things are affected with aging. Okay, so these are some age-related physiological changes. So this is more than enough for when you are writing on short notes on aging process. Okay, next I would like to briefly explain you the difference between biological aging and chronological aging. What is biological aging and what is chronological aging? So do you know the difference? Shweta, have you heard about the concept of biological or chronological aging? Have you heard these terms? Do you know the difference? So chronology means what?
Sequence, something in sequence.
So chronology means number. How old are we? Basically, it is a number. 10 years old, 20 years old, 30 years old, 40 years old. The number that we are able to count from our birth is called chronological age. Our actual calendar year or calendar age is called chronological age. In the image, I'm not sure if you're able to recognize. On the right hand side, you're able to see a very old lady able to hold her body on her arms. So she has so much of physical strength. So this a lady who trained herself to have so much of strength through a continuous physical activity. On the left hand side, do you recognize what is this condition here? Sam Burner, for example, is well known, famous for this. So any idea, or if you have seen Pa movie?
Yes, I've seen Pa movie. Yeah, I was able to recognize him,
Right.
but I don't remember the name of the disease.
Also a Hollywood movie, The Curious Case of Benjamin Button. Right, even that movie, they talk about reversing of aging. But here we're talking about a rare condition called progeria, disease called progeria. 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 So what happens? This person is probably maybe 15 years old or 20 years old. He looks as old as a 70-year-old or 80-year-old. So this is a rapid aging that happens in some people. So certain genetic changes in their body results in this. Those genetic components which are essential for normal growth development, but they're resulting in early aging. So progeria is one such condition. You can mention diseases like progeria have indicated about genetic components and their role in maintaining growth. So we're talking about two opposite scenarios here. This person supposed to be, not as aged as he looks like. On the other side, this lady who's supposed to be really aged has a lot of physiological capacity and strength in her. So these components that are reverse. Just wanted to show you an idea on this. So let's define what is biological aging and chronological aging. Okay, and look into a few aspects of it. So chronological age, as I was telling you, chronological is a number. Since our birth, if you count what is your age, that is what is chronological age. For an additional reading, I'm going to provide you. There was a newspaper article that came on this. Hindustan Times. Okay. When was it? Back in 2017, 2016 indeed. Article came like this. What is the difference between chronological age and biological age? Okay. Do we look aged or do we look young? So what is that? So when someone asks you how old are you, the number that we are giving here is the chronological age. But inside you, biologically, your age may be different. Maybe you're 30 years old, but you may be behaving like a 40-year-old. Maybe your physiological system, not talking about actual behavior, experiential behavior. I'm talking about how well your physiological system is functioning. The internal component is biological age. Okay. So there is something called Dunedin Multidisciplinary Health and Development Study. This is called a Dunedin study conducted by a university in New Zealand. They've conducted age-related phenomena in a well-known study called Dunedin study. The Dunedin study conducted by University of Otago, New Zealand. Okay, so they actually put some emphasis on chronological age and biological age, difference between chronological age and biological age. So what is chronological age? Make a note of it. Chronological age is the actual amount of time a person has been alive. What is chronological age? It is the actual amount of time a person has been alive. So it's your age based on calendar, beginning at your birth. Whereas biological age is our internal age of our organs, age of our physiological systems is biological age, which is determined by our lifestyle, genetics, exercise, sleep habits, etc. So what is biological age? Biological age is the real performing age or age of your physiological systems. Is your heart behaving like a 20-year-old or 30-year-old? Let's say your food habits, your activity, physical activity is not great. Your heart may age faster. So although you are at the age of 25, your body may behave, your heart may behave like as it is for a 35-year-old. So that is biological age. So biological age is the age of physiological components of the body, age of the physiological component of the body. How do you know it? It depending on the performance of that physiological component. I'll tell you how do you find out? Is it a way? Because chronological age is easy to determine. Just calculate the numbers of months and years beginning at your birth. But whereas biological age, which is affected by various factors, your lifestyle, your genetics, what genes did you receive? Are your parents or grandparents who lived long? You probably have those higher longevity. And do you do workout? What are your sleeping habits, food habits? All sorts of things can influence your biological age. Okay, so definitely chronological and biological age concepts are different. So chronological age does not necessarily contribute to the aging symptoms that we often see. As I was talking about foldings in the skin, loss of hair, graying of hair. So these things may not be the direct contribution of chronological age, but the biological age. Correct? Why some people feel sick or why some people actually start having difficulty in breathing. There can be different medical conditions for that, but your biological age is increasing more than the chronological age. So chronological age does not necessarily contribute to the aging symptoms we talked about so far. So chronological age may not be determinant of the actual health. It can provide you a clue about if you are 30-year-old, what would be your symptoms. 40-year-old, what would be the features that you would experience. But it may not be the real determinant of health. What is the real determinant of health? Must be your biological age. Okay. So one example that I can tell you here. Let's say some people experience pain in knee joints after crossing certain years, certain age, like 40 years old may start experiencing the pain in the knee joints. We are susceptible more and more to arthritis because we use those joints so much for walking, for sitting, for standing. Okay, and maybe depending on your profession. Plus, on top of that, we have something called synovial fluid. It's like lubricant in the joint. So this is actually reducing the friction. Even that fluid gets decreased. Because of that, because of the wear and tear, what happens? You start experiencing the pain in joints. But this may not be true for everyone. Some people may experience a problem in 40s, some people may experience a problem only in 70s. So do you see the individual difference? The difference is coming from the biological age concept. The difference here is coming from the biological age concept. So clearly, studies like Dunedin study done by New Zealand University, they are indicating that biological age is a truer measure or more important measure of our age than the chronological age. So what is a truer measure or better measure of your age? Must be your biological age. Okay, biological age should be a better measure, more truer measure of your age than the chronological age. But chronological age you can count, but how do you determine the biological age? We are recognizing that biological age is important, but how do you know your biological age? Is there a way for it? I've collected some information on this from various sources. So I'm summarizing that here. So already talked about these aspects. A child's biological age or maturation is not the same as and does not exactly follow the chronological age. There may or may not be correlation between your chronological age and biological age. I was already telling you, you may be 25-year-old, but your body may be behaving as 35-year-olds or maybe as 20-year-old. Both ways it is possible. Correct? And we all seem to have what is called a biological clock. So there must be a clock that is ticking, counting our time, which can either speed up or slow down depending on your quality of life. Okay, so children with the same chronological age or humans with same chronological age can differ as much as 5 years in biological age. There seem to be an average 5 years difference between our biological age and the chronological age. Okay, but now the question is, how do you know it? How do you determine biological age? Okay, this 2017 study published in eBiomedicine had briefly talked about the connection between chronological age and biological age. So here they're talking about on the x-axis adolescence, middle life, old age. How does our chronological age and biological age correlate? How do they correlate? So if you see here, we are seeing the central line that is going. This is the best case scenario. They both should correlate the same manner. Both biological age, chronological age should match. The best case scenario, we age as per the requirement. So middle life, middle adulthood. Let's say you are in your 40s, 40, 45 years old. So people who are actually just have a proper correlation, they may look as they're supposed to look in terms of their appearance and body function. But two ways are possible. You see in the bottom line, dotted line and the upper line, the bottom line is where, biological age is lesser than the chronological age. You look more younger for that age. So biological age is lesser than the chronological age. Or opposite is true. For a given chronological age, your biological age is more than what is expected. You're supposed to be 40s, you're supposed to look like this, but you may look younger or you may look older. So biological age may or may not match with the chronological age, as this graph is indicating. Okay, there can be three scenarios: optimal scenario, okay, a better scenario, and a more inferior or weaker scenario. All three of these things are possible. What is the red line here? The red line is the positive predictive value. How well can you predict the biological age based on chronological age? How well can you predict the biological age based on the chronological age? You can predict it better till the midlife. At later point of time, your prediction rate decreases, meaning the difference between chronological age and biological age will increase with time. What am I telling you here? You may be able to predict the biological age based on chronological age for certain duration, especially for up to adulthood, middle adulthood. But as we age more, the difference between chronological and biological age also increases. So what am I trying to tell you here? I'm trying to tell you that the difference between biological age and chronological age increases with age. This difference increases with age. Okay, so difference actually increases. So we use what is called, for biological age prediction, we use biomarkers. Remember in 9.6 we talked about biomarkers, or we talked about genetic markers. So some form of reference points or some form of markers we use to correlate the chronological age with the biological age, or to predict the biological age. Approximate biological age can be predicted by looking into few molecules, or which are known as biomarkers. And these biomarkers are useful in risk assessments for age-related conditions. So what are we learning here? I'm going to give you examples of biomarkers. For now, just make a note that we can use biomarkers to estimate the biological age, to approximately calculate, or in other words, estimate biological age. We can use biomarkers. What type of biomarkers? I'm going to explain that in a minute. And these biomarkers are useful in risk assessments for age-related conditions. So using those biomarkers, you can predict what type of problems may show up soon. Do you get diabetes? Are you going to get blood pressure-related issues? So what type of lifestyle changes are required? So like that, biological age prediction is greatly helpful to us in planning our life and avoiding any of those consequences of aging. We cannot completely stop them, but we can delay them, correct? We can delay them, we can postpone them. So also we notice that adult individuals of the same chronological age could show different risk for age-associated diseases, meaning whatever their chronological age is, depending on the biological age, people at 30 may develop diabetes, people at 50 develop diabetes when you compare two individuals. That age, not with respect to chronological, but biological age define the outcome of the diseases. Okay. Okay. So next, I think I already told you about this red line. The positive predictive value, the red line of biological age predicted decreases from midlife. From the middle age, you see that it is curving down. So meaning that your prediction or correlation between biological and chronological age will drastically decrease as we age. Let's now look into the examples of those biomarkers. What are those biomarkers that we can use to calculate the age difference? Okay, the most of the common ones here is telomere length of the telomere. What are telomeres? Telomeres are the ends of chromosomes. A chromosome, the tip of the chromosome on both sides. If this is a chromosome, we are talking about this end, tips of it. That actually it has been noticed that the length of those chromosomes decrease. Length of the chromosomes decrease. Length of the chromosomes decrease. And this telomere length can be used to predict the biological age. Excuse me. So telomere length is an example for calculating this, and there are other epigenetic biomarkers. Epigenetic. What is epigenetic biomarker? Do you remember? I think I was discussing in last class or a class before with respect to one of the topics, and also we discussed this in the yes, I think in the discussion during the discussion process, paper test to discussion, we talked about this. correct? Genomic imprinting. I talked about epigenetic changes or methylation like patterns change. So even that methylation pattern or epigenetic biomarkers can be used in predicting the age. Okay, and also predicting the risk for cancers, risk for non-communicable diseases can be calculated from that. So telomere length and identifying the epigenetic biomarkers like methyl groups. Okay, I was looking into this 2020 paper, 2020 research paper, which gave the idea about what are the different biomarkers that we can use to calculate the age factor. Okay, some of them molecular, like telomere length we talked about so far. Telomere length is a molecular marker. It's a molecule that you are looking at. Telomere length and DNA damage. DNA damage. Estimating the amount of DNA damage. There are specific methods for that. DNA MH. Okay, so there are methods that scientists have developed. So you can calculate the damage, DNA damage, with respect to something really specific, a common area which undergoes damage in our DNA. Excuse me, telomere length, DNA damage, mutations, somatic mutations, mutations in our somatic cells. So as we age, a number of mutations would also increase. So by looking into the number of mutations, you can approximately calculate or predict the biological age. Okay, telomere length, DNA damage, make a note of this. Mutations, somatic mutations or mutations in somatic cells. Excuse me, next, hormones. Hormonal levels. As we age, the balance between these hormones also decreases. So hormonal balance, ability to balance the hormones like growth hormone, insulin, etc. They can also help us predicting the biological age. Okay, there are so many others. Recently for COVID-19, we are hearing IL-6, interleukin-6, for example. This is a marker, inflammatory marker. So as your body responds to infection and if it causes inflammation, the proteins that undergo or elevate can also be used as a prediction. So IL-6, like inflammatory markers released during inflammation or inflammatory process. Okay, those are examples of molecular markers that we can use. Similarly, you can estimate the biological age using functional and structural aspects of your body parts. Functional estimation of functional aspect and structural aspect. Like for example, your arteries, blood that actually carried to various tissues from heart, your arteries, the stiffness in the arteries can be calculated. It is called arterial stiffness. Okay, stiffness of arteries or the blood vessels that carry blood to the other parts can be calculated. This can give us an idea about your biological age. Arterial stiffness. Then blood pressure. Blood pressure. So because at certain age, let's say you are 60 or in 70, having elevated blood pressure is common. It is acceptable. So age-wise difference you notice. So blood pressure can also guide us in determining the approximate biological age. Okay, these are two examples of the many things. Atherosclerosis or blockage of the blood vessels, cholesterol blockage of the blood vessels, calcification, amount of calcium that you find in different blood vessels. So these can be used as a means of functional and structural means of predicting biological age. Okay, right. These are sufficient for us. So in some cases, we actually have to collect the blood, collect the serum, urine, fecal matter to calculate it. Mostly for the molecular studies, we actually require a bit invasive methods of collecting samples. But for functional and structural analysis, you don't need invasive methods. Body scanning, maybe indirect methods of collection of data is possible. So non-invasive techniques can be used. So this is how biological aging is predicted, either through molecular methods or functional structural methods. Okay, right. Thereby we can get various ideas. I think we don't have to get into the details about specific names or methods for that, but the general idea is sufficient for us. Okay, so like that, our biological age. So what factors affect our biological age? Let's expand more on what factors, because chronological age is clear. We don't have to learn too much about chronological age. But biological age, what factors influence biological age? This should be the next subheading. Factors influencing biological age. Some of these factors we're already talking about with respect to growth and development. Our biological age is determined by, although they're focusing especially the vascular system in this study, but this holds true for overall biological age as well. So our chronological age, our normal process of aging, intrinsic concept of aging would influence biological age. So as the chronological age increases, so as the biological age. So definitely the normal aging process plus our lifestyle and our disease condition, disease status. Do you frequently get infections or not? What environment are you living in? What is your gender, your genetic components, your physiological, psychological factors, and socioeconomic factors? They all can influence the biological age. If you want, you can draw a flowchart like this. Okay, put the biological age in the center, draw a box here for biological age. Just say biological age here and put the arrow marks like this. Chronological age influences biological age. Chronological age influences biological age. Okay, I'll share this diagram with you either as part of the handout or separately, so you can use it. So chronological age, effect on biological age, lifestyle effect. What is the lifestyle effect? So what is your food intake, for example? Do you eat more meat or do you eat more nuts? What type of food do you eat? Can that have influence on your biological age? More healthier foods will keep the biological age low. I should maintain it well. Correct? Nutrition. So lifestyle examples, nutrition. Okay. Smoking, habit of smoking, habit of alcohol consumption, smoking, alcohol, drugs. Okay. So lifestyle, including the food habits, first point. Second point, like smoking / alcohol / drugs. Smoking, alcohol, and drugs, they can reduce your ability, so they can increase your biological age. Physical activity, what type of lifestyle you lead. Physical activity, are you physically active? Do you do exercise regularly? Plus your healthy sleeping habits. So these are some examples: food habits, other habits, physical activity, sleeping habits. Okay, so some of these, drug abuse, alcohol abuse, smoking, can increase the biological age. Healthy habits can decrease the biological age. Okay, this is about lifestyle. Then disease condition. What disease condition? Let's say you are going through type 2 diabetes. Are you going through any type 2 diabetes? Are you going through any autoimmune disease? Type 2 diabetes, autoimmune diseases, obesity. Are you obese? So these type of conditions, disease conditions, infections, and the other physiological conditions may influence your biological age. Obesity, type 2 diabetes, heart problems, kidney problems, they all increase biological age. Similarly, our environment, the fourth component here after chronological, lifestyle, disease condition, environment. Pollution. Do you live in a highly polluted area? Then biological age increases. Air pollution. Or environment during your birth time or during your early stages of growth, which are more sensitive to the environment. Unhealthy parental lifestyle during pregnancy. We talked about it briefly yesterday. I think Vishal was commenting on this, like unhealthy. So if environment is not right, so staying closely with the parents may not help. correct, may have a negative influence. So unhealthy parental lifestyle during pregnancy, alcohol consumption, those things, immediate environment can also influence the biological age. And even gender, sex. Males are more vulnerable than females. Females actually have longer lifespan than males. Females have longer lifespan than males. So males are at higher risk for biological increase in age and females are at lower risk, comparatively lower, few years difference. Okay, hereditary, your genes. If you are from a family where cardiovascular diseases, heart attacks, heart problems are common. So what happens to your biological age? Will it decrease or increase? It will increase. Cardiovascular, family history of diseases, hereditary conditions would increase the biological age. Same manner, if you are, I think I was already telling you, these grandparents live longer, like 90 years old. They had a longer lifespan. You probably can survive longer like that. So exceptional parental longevity. So longer lifespan seen in the family can also come to you hereditary. Okay, all right, what else? Socioeconomic status, low socioeconomic status. We talked about them yesterday. So low socioeconomic status may impact or affect the growth and development aspects. So as biological age. Biological age will increase with the decrease in socioeconomic status. It cannot be completely generalized, but yes, I think low economic status, for the reasons we discussed in yesterday's class, can impact the biological age. Okay, right. Next, psychological factors like stress. If you are in the profession where you have to go through too much of stress, or your family has a situation where you go through stress, also can influence your biological age. Okay, right. So these are the various factors that can influence the biological age. So we learned difference between chronological age and biological age. We learned how to calculate or predict biological age, and we learned what factors influence the biological age. Right? Now we'll move on to the aging theories. So because we finished here talking about chronological versus biological aging, we discussed. Okay. So we are in the third part of unit 10 because we finished stages of growth. We finished factors affecting growth in the second part. And the third part is aging and senescence. We talked about difference between aging and senescence. And we also talked about partly the fourth part, biological and chronological longevity or aging. Now we are going to talk about aging theories and observations. Aging theories and observations. Okay, so we talked about what happens once we go through the aging process, what physiological changes happen, but what causes them? We said senescence can cause it. So senescence is a process where we start noticing that cell loses ability to divide. Okay, but how do you explain the aging process? What might be the reasons or factors behind aging? Internally, what's happening inside our body and what's causing that defect? So for that, different scientists have come up with theories. These are called aging theories. I'm going to provide you a brief reading on this. I'm going to provide you brief reading on this. Okay, this is a book chapter, nicely fits into our requirement of the class. Biological and social theories of aging. Biological and social theories of aging. Okay, so the purpose of this chapter is to identify the current theories of aging, discuss both biological theories of aging and both genetic and non-genetic theories. So you can divide, we're talking about how different theories explain the process of aging. Here I'm going to introduce the concept of biological theories of aging, first one. So first subheading should be biological theories of aging. Within biological theories of aging, you can talk about genetic theories and non-genetic theories. So how in a biological context you can explain the process of aging? Okay, you can categorize. There seem to be over 300 or more aging theories. There are as many as 300 or more aging theories as per this source in the literature. But we, of course, we cannot learn about all of them. I think we are going to select the important ones. As per this resource, the major biological theories can be categorized into two types. Okay, genetic theories and non-genetic theories. What are they? Genetic and non-genetic theories. Genetic theories and non-genetic theories. Okay, let's look into some selected genetic theories. Look into some selected genetic theories. What I'm going to do, I made a brief summary and collected a brief summary on this. I'm going to talk to you a few genetic theories like programmed aging theory. We're going to talk about somatic mutation theory, free radical theory. So these type of examples under genetic theories and neuroendocrine theory, etc. I'm going to briefly explain you the concept. Otherwise, this resource I'm going to share with you for you to read. Okay, but let me explain the concept. Understand the concept behind these theories. Okay. So the first theory is programmed aging theory. We'll talk about programmed aging theory, which is also known as Hayflick limit theory. Hayflick limit theory. So what is Hayflick limit theory of aging? So you need to be able to explain few theories of aging. This is also something that is commonly asked in the exam. So know few theories of aging. One of the first proposed biological theory of the aging is study done by Hayflick and Moorhead in 1961. So the study done by Hayflick and Moorhead in 1960s. Okay, this is called Hayflick limit theory. So what are they talking about here? They're talking about cells have time clock, meaning there is a clock inside our body, which is ticking since our birth. So it is counting our age. So cells might have a time clock, meaning they might have an expiry date, meaning probably cells are only good for a few days. I think I was telling you, it depends. Like RBCs are good for about 4 months, 120 days. WBCs are good for about 10 days. Sperms and egg are good for about 5 days. Eggs are good for 1 day. Like that, there is an inherent time limit to them or expiry date to them. Right? So cells have limited lifespan. After that lifespan, they undergo what is called apoptosis. They undergo what is called apoptosis. Make a note of this word. Apoptosis means programmed cell death. Apoptosis refers to programmed cell death. So what is programmed cell death? So cell is designed in such a way that after a certain duration, it will die off. So where it receives signals from the cell to remove its nucleus, disintegrate various parts of it. So cell eventually starts showing the death process. When cells die, tissues die. When tissues die, we start seeing the effects of aging on our body. It may not happen right away, but they do die. But usually we have ability to replace the dying cells. They showed that this Hayflick and Moorhead have showed that there are functional changes that occur within the cells. So within the cells, some changes like this happen, and they are responsible for aging of cells and organisms. So at the cellular level, this apoptosis is taking place. Okay, then what happens? Eventually, we have our tissues getting affected. If tissues are affected, organs are affected. If organs are affected, our overall physiological function is affected. So like that, at cellular level, there is certain duration till which cells are all right. Later, cells would die. Later, cells would die. Okay, so there must be a genetic clock, internal genetic clock present in us, which is responsible for the aging according to the theory. Okay, then what happens? We are able to replace the dying cells, but how many times they can replace? There is limited number of replications or renewal. It's like renew. How many times you can renew it? Let's say download a software. How many computers you can actually download it? There may be a limit. In the similar manner, for this, the replication, sorry, for the replacement process, there's certain times they can replicate. So the genetic clock manifests as a predetermined or limited number of cell divisions. This is what is called a Hayflick limit. When they said, when I was talking to you that it will be a program to die, apoptosis is done, but there may be a count on how many times cells actually divide, how many times it should be allowed. Let's say approximately 50 times. Let's say approximately they divide for 50 times. After that, cell cannot divide, it will die. So this is number of limitation on the number of cell divisions. This is what is called Hayflick limit. This is called Hayflick limit. So limited number of cell divisions or limitation on number of cell divisions. Okay, so this is about Hayflick limit theory. Next, very important, well accepted theory is telomere theory. Telomeric theory. So what is telomeric theory? Telomeric theory in a way can be seen as an extension to Hayflick limit theory. It can be seen as an extension to Hayflick limit theory. So here, I think I was already telling you as one of the factors for biological aging is the ends of the chromosomes tend to become short, short and short in every replication cycle. So what did scientists identify or notice or observed? That over a period of time, as we age, the size of the chromosomes decrease, and especially the tips of the chromosomes become shortened. So this is telomere shortening, it is called. Telomeres are ends of the chromosomes becoming shorter and shorter with progressive cell cycles or cell divisions. Correct? So what happens if the ends of the telomeres or ends of the chromosomes become shortened? Okay, and why does it happen? So why you notice shortening of the chromosomes in each cell division? It is continuous process with cell division after cell division, the size of the telomeres decrease. And to the point where when they become too short, with the size of this, meaning that should happen after multiple cell cycles, cell divisions, right? Let's say this is a normal size of it came down to this much. This may be the limit. It cannot further continue to divide. Cell will die now. Cell will say my telomeres have become too short to survive. Now kill me. So like that, the telomere shortening may result in this process of aging. So why? Because they normally say the ends of the telomeres are important for the stability of the chromosomes. So when telomeres are gone, stability of the chromosome is also lost. Ends of the telomeres are also lost. Okay. So here what is happening after every cell division, the tips of the chromosomes become short. Why do they become short? They become short because the ends of the chromosomes don't replicate well. There is a problem inherently in the replication process. There is a problem in replication of the ends of the chromosomes. The ends of the chromosomes cannot be replicated, okay, normally. So what happens? They become short and short to a point where they become too short to undergo further cell divisions. Thereby, cell will stop to multiply, it will die. So this theory is called telomeric theory. So this comes from the observation that chromosomes become short with cell divisions, with ongoing cell divisions. Okay, this is called telomeric theory. This is called telomeric theory of aging. Excuse me. Next, we'll talk about error theory. Errors that takes place in our body. Error theory it is called. So error theory was given in 1963 by Orgel. So error theory, understand the concept of it, is given by Orgel in 1963. The concept is simple here. So as we age, the internal components in our body can be damaged, can undergo damage, can undergo insults, and they accumulate errors. So as we age, accidents may happen or errors may be introduced. Let's say in DNA replication, the process of DNA replication may not work at the same way. So maybe mutations are more and more mutations are introduced into your DNA. Okay, that would result in accumulation of more and more errors. Accumulation of errors over a period of time happen here. So as more and more errors accumulate, what happens to your cell function? Cell function gets affected. So simply this is a concept where as we age, okay, errors gets accumulated, more errors results in lesser ability to control the body's function. This is called error theory. So this is also a genetic theory. We're talking about genetic and non-genetic theories of aging here. One genetic theory of aging here is the error theory. So Hayflick limit theory, telomere shortening theory, and error theories we talked about. Excuse me. Okay, right. So next, I think as I was telling you, I wanted to refer to the theories that are explained here. But genetic theories we talked about, programmed aging or Hayflick limit theory we discussed about. Okay, and we are going to discuss somatic mutation theory and neuroendocrine theory as well, and free radical theory. So 4 or 5 examples of theories we discuss under this category. Okay, error theory is one of them. This is also genetic theory, and another very important theory is the free radical theory. So what is free radical theory? So free radical theory refers to the concept where how free radicals that are formed in our body, let's say in the process of oxidations, we have oxidation that normally takes place in the body. Oxidation is a normal biochemical process that happens in the body. Energy generation, we require oxidation. Okay, fatty acids, you want to create smaller versions of fatty acids, we need oxidation. So oxidation is a common phenomenon, and oxidation results in free radicals. Free radicals are nothing but charged species. They are charged elements. During the biochemical processes in the body, our body generates free radicals. In brackets, you can write charged species. As you see here, positively charged and negatively charged species that you see here, these are called free radicals. These free radicals seems to damage our body. Free radicals can damage various parts of our body. Like if you see, this is a cell and this is a cell membrane. The channels, proteins that are acting like the gates, they can undergo damage. Our DNA can undergo damage. So these free radicals can damage many parts. That is what you are seeing in the image here. Proteins, which are playing an important role in cell function, and DNA can undergo damage. Lipids in the membrane can undergo damage. Even most importantly, mitochondria, which is powerhouse of the cell, can also undergo damage. Powerhouse of the cell can also undergo damage. Okay, free radical theory. So we are learning how free radicals can cause aging process. So explain to you what are free radicals, what produces them, and we are talking about what aspects of our cell is affected by the free radicals. And this is a proven one, meaning free radicals are proven to or demonstrated to cause these problems. Okay, with age, abnormal mitochondria. With age, we notice abnormal mitochondria. Abnormal mitochondria increase with age. And also ionizing radiation. When you are exposed to the high energy radiation, like X-rays, gamma rays for a longer duration, what happens? Your tissues get damaged. That is because of the ionization nature of the radiation. Radiation can result in ions like this. And some enzymes like superoxide dismutase, okay, don't have to write down the name. Some examples of enzymes undergo change in trisomy 21. So the age related early aging happens in trisomy 21 because of some of these changes. Okay, so like that, free radicals can impact various components of the body, various components of the cell, thereby leading to aging process. Okay, so this is one theory called free radical theory. Okay, this has been explained here. Free radicals and unpaired electrons and free electrons, how do they cause damage? You can read from this paragraph. Okay, so last one is neuroendocrine theory in the genetic changes. Neuroendocrine theory. Neuroendocrine theory. So this was given by Denkla in 1974, who is an endocrinologist and gerontologist. Okay, so here people, depending on what perspective they are looking into, molecular biologists, geneticists, endocrinologists, they have seen aging as a different process, or aging is caused due to different process. So Denkla, endocrinologist and gerontologist, he talked about aging mediated in the brain. So the processes that take place in the brain results in aging as per him. So aging mediated in the brain. So functional decrements in neurons and associated hormones, what results in aging according to them. So what are the key aspects of central nervous system functioning? Nerves are the key units of our brain function. So functionally or gradually they lose the ability in their function. So functional decrements in the neurons functioning, or functional decrements in neurons, or functional changes in neurons, decrease in functionality of neurons. So what happens? They cannot communicate well. If they cannot communicate well, they cannot coordinate well. So aging process may happen because of these factors related to brain. One is the functioning of neurons. Second one is the hormones. The other way of dealing or controlling our body's aspects, as we were talking about in the growth factors, is hormones. So not being able to associate well with hormones and regulate through hormones can also result in aging process. So changes to the components of our nervous system like neurons and also hormonal system may result in the aging. This is called neuroendocrine and hormonal theory, or simply neuroendocrine theory. Examples of Parkinson's disease, Alzheimer's disease, aging symptoms, certain aspects of brain which are supposed to function normally, but irrespective of aging, sometimes they can undergo these changes, resulting in the early aging problems. So in Parkinson's, being able to control the muscular movements, body coordination will miss. Whereas in the Alzheimer's memories, early memory loss happens. Okay. So they indicate that how important is brain and few components of the brain in aging process. Okay, so these are examples of genetic theories of aging. Okay, and there's only one example for non-genetic theory of aging. Non-genetic theory of aging. That is wear and tear theory. What is it? This is called the wear and tear theory. So what does it mean? The concept is very simple here. Wear and tear means as we age, wear and tear happens to the various parts of the body, our tissues, especially our joints. So we start using them, and as with the usage, they will be damaged. More and more usage results in more damage to it. So this is a wear and tear concept where cumulative damage, accumulated damage within the body leads to death of cells and tissues, thereby results in the aging concept. What is it telling? It says that cumulative damages to the cells, cumulative damages to various parts in the body like cells, leads to death of them and thereby aging. But we do have a mechanism to fix this problem, because wear and tear is a natural process. And organisms are able to repair the wear and tear, but what happens, the ability to repair them would be lost over a period of time. Like DNA damage repair, we can only do so for some age. Later that ability will be reduced. Like that wear and tear, eventually what happens would result in accumulation of those changes, which leads to aging problem. Just give me one minute. Okay, sorry guys, just have to send something quickly. Almost done. Okay, right. Thank you. So wear and tear and theory is that they have studied this in identical twins. Identical twins are studied for various such aspects of how wear and tear can increase or show the differences in them. Okay, so this is a non-genetic theory. Here it is not a genetic component or cell component that is leading to this problem, but it is a regular usage of the various parts of our body can lead to this. So these are some biological theories of aging. What did we learn in the biological theories of aging? We talked about few aspects of theories here. So biological means of aging. We talked about Hayflick limit theory. Hayflick limit theory is where we have only certain ability to continue the replication of cell divisions. There is certain limit on that. After that, number of cell divisions will stop, cell will die. This is called Hayflick limit theory. The next one we talked about is the telomere shortening theory. With continuous cell divisions, the ends of the chromosomes that are telomeres become short and short to a point where chromosomes become too unstable to further multiply. Also results in the aging process. This is well observed. And we talked about errors, error theory. Errors accumulate with age, thereby affecting the functional aspects of the various cells and various components of the body. Another biological theory we talked about is the free radicals generated during the process like oxidation damage many different components, cellular components, thereby resulting in age. And another one we talked about is the neuroendocrine theory, where the effects on the brain, central nervous system, and associated things would result in the aging process. So these are the brief ideas about what are the biological theories of aging. We talked about genetic theories, non-genetic theories of wear and tear theory we talked about. Next, we are going to talk about the aging in sociological perspective or social perspective. Okay, aging as in a social perspective. So, which is in social context, how do you see aging? So, you see certain difference here. In biologically, we explain the processes behind aging. Socially, we see what should be done, in what context aging can be taken. So, the way we approach socially is different from biologically. Okay, as I'm going to give you this component here. They have briefly explained the concept of social theories of aging here. There are again several different theories of aging, especially in the countries like Americas, for example, where there is increased number of elders in their society, resulted in more emphasis or more attention towards the aging process. And what happens, as we know, with aging, quality of life decreases. Quality of life decreases. Okay, so quality of life decreases with age. So there are three theories that explain how should we take the aging process in the social context. There are many theories, but I have seen in the literature, there are three theories that they talk about. They are called major social theories of aging. These are activity theory, disengagement theory, and continuity theory. There are three theories I'm going to explain here. Activity theory, disengagement theory, and continuity theory. So there are three major social theories of aging. Activity theory, disengagement theory, and continuity theory. Let me explain what are those theories. So what does disengagement theory talks about? We are seeing in the social perspective. Okay, the role of elderly people we are talking about. We are not talking about the causes. So the way we look at it is changing here. So disengagement theory is what? So to enable the younger people to assume important roles, a society must encourage its older people to disengage. Understand the concept, write the keywords. I'm going to provide you this reading. Okay. This table will be provided to you as part of the resource that I'm going to show you. So disengagement theory, disengaging the elderly people from the system is what the aspect they're looking at. Why? To enable the younger people to assume or take over the important roles of the important roles that are done by these elderly people. So to allow the young people to take over the elderly people's work in a way. Enable younger people to assume important roles. So for that, a society must encourage older people to disengage from their previous roles, meaning a concept of retirement. We're talking about concept of retirement. After a certain age, they won't be able to perform them effectively. So let them disengage and substitute them with more younger people. So this is to enable younger people to assume important roles. A society must encourage its older people to disengage from the previous roles and to take on roles more appropriate to their physical and mental decline. So after a certain age, they are probably able to perform only certain functions effectively. They should switch to those functions and retire from this type of important work. This is to find good effective work progress in the given system. So this is called functionalist explanation of aging process. This is called functionalist explanation of aging process. So elderly people should disengage and young people should take these important works. And they're not asking elderly people to completely retire, but to participate in the other physical and mental tasks that can satisfy their abilities. This is called disengagement theory. The next one is called activity theory. Activity theory. Activity theory. Okay. Next one. So activity theory means what? Older people benefit themselves in their society if they continue to be active. Activity theory. This is also called continuity theory. So what happens here? Older people benefit if they continue to work in the society, continue to participate in their work. They have to be active, continue to be active. So that what happens? Their positive perceptions of the aging process, their experiences. It's like this, for any organization, you need experienced people as well as the young people. Experienced people with their experience will train you, will guide you in the right direction. Young people will give you more energy. So here they're talking about the aspect of continuation of the elderly people and participation in a given function, in a given work. Okay, so they can benefit the society better if they continue to work. Here they are kind of talking against the concept of retirement. They let them work as far as they can manage, rather than putting a deadline on, when they should retire. They need to be continuously active or continue to be active, utilizing their positive perceptions of aging or their experiences, in other words. Okay, so this is called activity theory. Continuation in work, continuation in participation and contribution, which helps the society better. This is called interactionist version of the aging, interactionist of aging. The previous one is considered to be functionalist explanation of aging. This is interactionist explanation of aging. They continue to contribute to the society through active participation. Okay, right. And then another theory is called conflict theory. Conflict theory. So this is more generalized version of theory. So what is conflict theory? It talks about that older people or elderly people or older people experience age-based prejudice. So the way we treat elderly people is different. You say you're not fit for this job because you're aged. You see these type of things in the, like for example, in airline industries. Air hostess, for example, age is a criteria for that. Marriage is a criteria for that. So for certain jobs, we notice that there is a bias, there is a prejudice, age-based prejudice and discrimination. So this leads to inequalities among the aged exist along the lines of gender, race, and social class. Same as how we discriminate on gender, race, or ethnicity or social class, age-based discrimination also happens in given societies. So in a way, this can be considered as more general conflict theory of society. This can be considered as more general conflict theory of society. Okay. There was one very short note on this that I'm going to share with you. For biological theories, we refer to the previous one. This table is part of the sociological perspective of aging that I've collected from another online source. Okay, this theory, this table I've taken from there. They also gave some factual data about who gave what. So disengagement theory given by Cumming and Henry in 1961. Okay, they briefly explained the concept here. And also activity theory. Okay, Jong and Miller. Okay, I've given them in 2000s. They also briefly talked about the criticism related to that. We just talked about activity theory, for example, that mainly appraisal of the ability of the elderly to maintain their level of activity is too optimistic. The problem is how well they can maintain those ability to continuously be active. That is being too much of optimistic. Okay, so there are certain concepts of criticisms are also possible here that you can have a look at it. Like for conflict theory, there's an age-based bias that we talked about. One criticism for conflict theory is that it blames ageism on modern capitalist economies. So we cannot blame the concept of aging and age-based discrimination where there is a practical need for that. Okay, so definitely, I think you can see that some of these theories would touch on some of the key aspects of participation of aged people or elderly people. The way the biological theories are placed and the way social theories of aging are placed are different. Biological theories mostly looking towards the origin and the cause of aging, whereas these theories are mostly focusing on the involvement and aftermath of what should happen after aging process or in the process of aging. Okay, right. So I'm going to share these reading with you. I think this is something that is frequently coming in the exam. This is one component I have seen related to the aging process that frequently comes in the exam. Excuse me. So if you see the past questions from this part, so questions are straightforward. Majority of them were discussed in the class. One question was 2019 question. This was discuss the methods of studying human growth with their merits and demerits. Mainly you should focus on longitudinal studies, cross-sectional studies, merits and demerits. Mention briefly about cohort studies and twin studies. Direct question. Routinely comes in the exam. Okay, we discussed enough on this that you should be able to answer them. I'll give them in the test to see how well you can write them or present them. Okay, and what else have come related to this? Same 2017 question. Describe the various methods of studying human growth, highlighting their merits and demerits. Same question in 2017 and 2019. It's a very common question. In 2015, a short note, longitudinal method of studying growth. Question came on longitudinal method of studying growth. Define what it is, give an example, limitations and advantages of such method.
Sir, for the previous question, discuss methods and then merits and demerits. So, should we go with the format we studied yesterday, where we show merits and demerits of longitudinal, cross-sectional, and then a brief note on, say, cohort, maybe, and then a case study?
Yes, you can definitely go with that or individual. It's up to you. Comparative is better, easy, it saves your time. Okay, at the same time, it should not look too short for you, right? But if you cover all the key points of it, that should be all right. Other method is to take one after other, cross-sectional, longitudinal, but have the subheadings. It's up to you, depending on the time situation and whether it is 15 marker question, this is all right. That method is all right. Okay, so this is one common question that we see. I think we've discussed enough. I've given content on that. And the genetico-environmental factors affecting human growth. So what factors? Genetic factors, environmental factors affecting human growth. We talked about them. What are genetic factors? What are the environmental factors? Explain that 10 marker question in 2019. So short note. You can easily write on this, right? So 2016 question. Discuss different factors affecting growth and development in human beings. Discuss different factors affecting growth and development in human beings. Same question, but they have not specified what to discuss here. We talk about various things, biochemical factors, so endocrine, and as well as nutritional factors, cultural factors, socioeconomic factors, briefly discussed. Okay, what else? Aging and senescence. 2013 question, aging and senescence. They simply gave aging and senescence. Define aging, define senescence, talk about how senescence lead to aging. So 10 marker question. So we briefly discuss some of the aspects that we discussed in yesterday's class and today's class. So questions are straightforward from this unit. Okay, so other question that is given here. Issues of elderly and senescence in developing and developed countries. So they're asking about issues related to elderly and senescence in developing versus developed countries. You can put into the context of what we discussed in the trends in epidemiological anthropology. What are the different problems that cause issues in developed countries and developing countries? Non-communicable diseases versus communicable diseases. How the factors that influence the aging different between developing and developed countries, starting with the diet, lifestyle, environmental factors, different types of diseases. Focus on them. This is a 2018 question. So you give the comparison between the developing and developed countries with various factors affecting the process of aging and senescence. Okay, we'll discuss it. I'll give you this in the test so we can actually discuss this question and points related to that. Okay, what else? Aging theories. Yeah, factors. One more question came in 2013. Justify, though human growth is under tight genetic control, but it is influenced by various environmental factors. Though human growth is under tight genetic control, meaning genetic control has an important role for defining human growth and development, but it is also influenced by various environmental factors. Meaning they're asking what is the role of environmental factors in growth and development. So question can also come like this. 15 marker question came like that once. Okay, what else? Theories. So explain two biological theories of aging based on purposeful events. Explain any two biological theories of aging. Okay, so you can pick up two theories of that we talked about, genetic theories of aging. Okay, explain them in detail. Okay, the handout that I'm going to, the reading material I'm going to give you would help you discussing this in detail with some specific key points that you need. Okay, like that. So questions are coming like this. I think you should be able to answer majority of these questions. Now we are left with the last part of this unit. Okay, we finished rest of them. Fourth part, methodologies for growth studies are also done. So what are we left with is a human physics and somatotyping. Biological, chronological, longevity also I covered today. So human physics and somatotyping is the last topic from which questions are also frequently coming in the exam, which I'm going to discuss in tomorrow's class. I'm going to cover tomorrow somatotyping, various methods of somatotyping, comparison, few methods we have to talk about. Mainly two methods that we have to talk about, Sheldon method and Heath-Carter method, plus other traditional methods of somatotyping. And with that, we'll finish unit 10 first half tomorrow, and then we'll start with the unit 11 tomorrow, fertility and fecundity. So tomorrow we can wind up 10 and start with 11. So in another 2-3 classes, we can wind up 11. So mostly by the end of this week, I'll finish the 11th and also start with the 12th unit. Okay, that is the aim for this week. So I'm going to
the previous question
yes.
About where we are talking about the environmental factors. So does it make sense to write a case study that we discussed for twin method, the obesity?
Yes. Yes, you can talk about how environmental factors like obesity or pollution, fetal, alcoholic syndrome. So those type of examples you can cite. So list a number of environmental factors playing the role and where possible with examples. Okay, collect that type of information. Okay, I think you posted something on a case study. Am I right? I've not noticed.
Yes, sir. It's about a longitudinal. I think it's a cohort study of effects of alcohol.
Energy drinks consumption.
Energy drinks, yes. There was also a study on alcohol recently in Hindu.
You will find n number of longitudinal studies and crosses. They're very common. In the newspapers also, you frequently hear this. You'll understand more of its importance as we go through more and more examples of it. But you will find n number of cases for longitudinal studies and cross-sectional studies. I have so many of them with me, but I felt the one I've given the example is sufficient for our class. Okay, so pick something that you find more interesting, more recent, more popular. You can give. I've only given you idea about how to actually show a case study related to that. Okay, right? Any other questions? So tomorrow, I think we're going to have the session as usual in the evening. There, I think we're going to finish 10 and begin with the 11th unit. Okay, right. Thank you. Have a good day.